Welcome to TYC Materials Modeling course. Materials modeling is multi-scale, so it includes electronic structure at static and dynamic level, and then at a higher level of scales. Say when we come to nanometers and higher, then we talk about mesoscales, where we usually discuss about dislocations, grain boundaries, and surfaces, and then we move up in scales to dislocation dynamics when we may be talking about micrometers and millimeters, and then to plasticity and devices. So this course is focused mainly on two initial scales, which are operated at nanometers, which are electronic structure, and then molecular dynamics methods and kinetic Monte Carlo. So talking about methods, what we'll be talking about will be quantum mechanical methods, including quantum chemistry and density functional theory, as well as molecular dynamic methods and kinetic Monte Carlo methods, which will comprise the first part of the module. Then after that, we will move to problem solving. And so the course itself is organized into two terms in a way that actually the half of the first term in October and November will be focused on density applications of density functional theory and its basics. And we'll finish in the middle of November by this lecture by Tom Darren, which will discuss DFT practicalities. After that, second part of the November and December will be focused on molecular dynamics and kinetic Monte Carlo, which will be presented by Johan Blumberger, and then Mikhail Stamatakis and Matteo Salvaggio, who will introduce you to intricacies of how to operate these methods. Then in term two, we are going to talk about applications of these methods, for example, kinetics and thermodynamics of nucleation, relation between classical force field and interatomic intermolecular interactions, and then development of interatomic potentials, which are important for these simulations, like fitting force fields. The second part of term two will be focused on calculation of properties like vibrational properties, electronic excitations, using quantum Monte Carlo and other techniques. So the whole duration of the course is 2 terms, and it will be organized in a way like never before. So in terms of delivery, pre-recorded lectures and notes will be posted on the TYC website 1 week before the date of tutorials. So date of tutorials, which I was showing here, so the first tutorial is on October 7th, so you should expect some pre-recorded lectures like this one, which you should be looking at now, uploaded to the TYC website, which you should have information about. And then, after you have studied what has been uploaded there, we'll have a tutorial, which will be at 1 o'clock on Wednesday through Zoom, through this address here. So the purpose of these tutorials will be mainly to discuss questions which you may have from studying these materials, which will include not only lectures and notes, but also maybe some other suggestions, maybe papers, which people may want you to discuss. So you are invited to actively study all of those, and then come back to us for these tutorial sessions in order to, on one hand, ask questions, which we will hope to be able to address. So these sessions are going to be interactive, and we'll also be sharing some examples from real-life simulations with you for doing that. So thank you very much. And so now you may need to look at the first installment of this first